Rodrigue, I think that we can start.
Yeah, no, it's okay for me. Let's go. Now you're loud. You can start, Simi.
Okay, good. Good morning, everyone, and thank you very much for joining us on this second session for the Archie Fridays event. So I'm thrilled to welcome you all in today's session, in this 1 hour session organized as part of the Archie Fridays events. Which is vibrant initiatives driven by community passionate about enterprise architectures and data management, data architecture too. My name is Sami Ben Salem. I'm a data architect, and I have the privilege of co-hosting this session alongside with my friend Rodrigue Yengo. And today we will dive into a very interesting key topic surrounding enterprise architecture and data to explore practical and innovate perspectives to address today's challenges. Giving the words to my friend Rodrigue to introduce himself and also the Archie Fridays events before starting the session.
Okay, thank you, Simi. To start, just a few words about Archi Friday. As you said, Archi Friday is a weekly community event where we invite inspiring speakers to share insight on architecture, mindset, and innovation. It's a kind of informal life and always focused on practical value and human connection. We are honored today to have you with us and Mihaela also. And Mihaela, your topic speak directly to the heart of what we want to explore with our audience, going beyond code and building with purpose. Also, congratulations on your recent MVP renewal. It's a real
Yes,
testament to your impact.
congratulations.
So let us know if you need anything before we go live. Otherwise, we'll begin the session at we plan the right time. So the floor is yours.
Okay, thank you very much.
You're
Also,
welcome.
let me share my screen. I'll share my green forest again for now. Okay. Okay, let's see. Can you see the first slide for?
Yes, good.
Good? Yep, perfect. Okay. First of all, thank you very much for having me. It's very, very nice to be with you, even though it's not in person. Still, it's good that technology allows us to do this. I really liked what you were saying before about the challenges that us trying to overcome all the challenges that we have right now in tech and also adjusting to what is happening. And basically the presentation that I'm having today also has this in sight, looking a bit on how we can use our edge as developers, as real people, our minds in order to build products that will actually go over no matter what trend, no matter what changes in the tech landscape. So this is pretty much the objective. A little bit about myself. I'm a software engineer at the base, of course. But when I'm not doing techie stuff, like writing code and all sorts of things in my day-to-day job, I like to prepare content on, topics that I find interesting, that at some point I would have liked to learn about in order to share it further, learn from other experiences, other ideas that the people that I talk to are having. Of course, as I was saying, as a day-to-day job, I'm a technical lead at Signant, Microsoft MVP, uh, just got renewed. So this is a very, it's very nice that I get to do this presentation, in the new cycle. Is very exciting to start already. Very nice. And when I'm not in the, in this techie environment, I like to just stay outside of my house, either go hiking, cycling, doing something that, it's outside in nature. So this is pretty much about me.
Thank you.
I guess we can move further, right?
Yeah.
Okay, so I don't know how many of you know this building, but I'm guessing, yeah, Florence is a very popular vacation destination, since we are in this also in the season right now. So this is the Cathedral of Santa Maria del Fiore, and the interesting part about this is that it took 142 years to be built. Yeah, somewhere around this time. It has somewhere around 4 million bricks, and yeah, you can see all the complexity that it has in its design and architecture. So it took a lot of time. So to make a joke, just think about when someone is asking you to build something in 1 month or something like this, if you have something as impressive as this one. And imagine that you're standing at the base of this building, or a skyscraper, right? And you're looking at this design, right? Let's just do this imagination exercise. You see every window, every floor, every detail is planned. Each element is serving a certain purpose in this overall ensemble that we are seeing. And now think about the architect who designed it, right? Because before the first brick was actually laid, they had to envision not just how the building would look, but how it would stand the test of time, windstorms, serve occupants for the decades to come, or a lot of visitors, right, for decades and decades. And now let's shift this perspective, because I just love always looking at both these domains. I have actually a friend that it's an architect, architecting for buildings, and we always exchange ideas. So I want us now to shift that perspective to the world of software development, right? As developers, as architects, we're often focused on immediate tasks, right? We like it or not, we always have, deadline, some date by which we have to deliver, writing code, fixing bugs, deploying the new features, always in the cycle. But what if, just for a second, we approach our work with the same mindset of the architect that worked on a building, as we were imagining before, right? What if, instead of just solving today's problems, we started designing systems with the same precision, with the same purpose as someone building a house, right? As someone building a skyscraper, a cathedral, whatever that is. So just as an architect considers the life cycle of their building, from construction to maybe at some point being demolished, we too should think about the entire life cycle of our software. How will it evolve? How will it handle increasing demands? How will it continue to serve the users in the years to come, depending on also how users are going to evolve, how their habits are going to evolve, how their needs are going to evolve, and so on. And I want you to keep in mind this analogy for the entire presentation, because I really think that, especially now in all this beautiful chaos that we are having with AI around us and surrounding us, and yeah, all the discussions that are happening around us on this topic, we should look at our work at more than just coding. We can actually look at it as, we are designing some skyscrapers on our work too, because we often find it challenging to step outside our products, right, and look at them as a whole. Just when you're building, right, a cathedral, for example, right, we have the ability to go outside of it and look at an entire physical construction, right? But in software development, we don't have the same limitation. We don't have the same possibilities, right? For example, in the physical world, building a house with doors pointing in all directions would be very impractical, right? You can't use that. It might seem interesting, but you can't really use them. But in software, we do this kind of crazy stuff all the time, right? We have freedom, we have flexibilities, we can be very creative, but at the same time also this kind of decisions can lead to very bad results. And I'm sure that, you know, all sorts of scenarios are appearing into your head right now, or previous experiences. And despite this freedom, it's very interesting, because when we discuss perspective, of sticking to the familiar, you know, the patterns, the rules, the standard methods. And sometimes I'm looking at in conferences, you know, joining maybe presentations that you know, are coming with something very new, very or trying to look at things from another perspective. And I look at, you know, the crowd and their faces, and they are like, oh no, 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 like I know a way of doing this, and this is, what's this new thing? So even when we actually try something new, we don't fully embrace it, right? It is more comfortable, and this is a human kind of trait. Is more comfortable to hold on to our existing beliefs than to confront the discomfort of our outdated or false beliefs. And this, I'm looking, is also happening right now, again, in the context of AI and everything that is happening. But reflecting on everything that comes our way is crucial for learning and for growth. And by breaking, you know, this cycle of thinking, right, through reflection, we can adopt a growth mindset that leads to better decision and a more fulfilling, work experience in the end, right, as a whole. And what I mean by mindset, I mean by attitudes and the beliefs that shape how we approach our work, how we solve problems, how we tackle challenges. Is the lens through which we look at our everyday work, our tasks, our challenges, our abilities, actually, you know, and also the potential of development further. And I want us to stay a bit on this topic of mindset, because I think it's very important, especially for people in the organization that are making decisions, you know, but also as a whole for everyone. Again, especially now that we are having tools that can do a big part of the you know, the coding and the work that we are doing. We are looking at how we are going to just adapt in this new context by using our mindset, or by being aware of our mindset. And let me just put it into two examples. So if you've ever thought, I'm just not good at algorithms, or I never understand whatever framework, instead of, I don't understand this yet, but I can figure it out if I'm working, if I'm learning, if I'm searching for all sorts of trainings and so on. This means that you're tapping into a fixed mindset, right? And this perspective limits your growth because it creates this mental barrier for learning and adaptation. And by doing this, you know, I can see this every time. Developers with a fixed mindset shy away from challenges, fear that failure will expose their limitations, and in the end, we end up avoiding new technologies. We stick to the familiar, even if it's good or bad. We just stick to it because at some point it worked. Doesn't matter if this context is a bit different. We resist feedback, because it threatens our sense of competence. On the other side, a growth mindset is the belief that, okay, abilities and intelligence can be developed through learning, dedication, effort. And for a developer with a growth mindset, every project, every line of code, every new technology, every new challenge is a chance to grow and improve. And I strongly recommend this this book, The Black Box Thinking, because it has a very, very interesting parallel between growth and fixed mindset, and is going to even make more sense. So basically, in this Black Box Thinking book by Matthew Syed, a key part of the book draws a comparison between the aviation industry and the medical field. And then we have the aviation industry that exemplifies the growth mindset, by using the black box, the flight data recorder, in order to understand and learn from mistakes, right? So after every crash or serious accident, this data is analyzed to uncover what went wrong in order to learn and prevent future failures. On the other side, we have the medical field that is being presented as more resistant to admitting and learning from mistakes. And very nicely in the book is presented that in this field, as opposed to aviation, errors are often hidden or ignored because somehow in this industry, there is this fear that admitting mistakes could damage the reputation of the person or expose them to legal consequences, right? So as a result, errors often go unreported or just dismissed, and this creates a limit for learning and improvement. And what we need to learn from this is that we need to be learning. We are not going to do an exercise right now, I'm just going to leave it for each of you to do it, but we need to be honest and reflect on where we stand. Are we more like the medical example or the aviation industry? Do we have a growth mindset or do we have a fixed mindset? And regardless of the answer, and no matter where we currently stand, I'd like to shift the conversation towards growth today. I want to share a story that I heard some while before. I don't know who is the author or who said it first, so whoever did it, I give them credit. I just heard it at some point, but it's got stuck with me, and then lately it just kept coming back more and more when thinking about, okay, what am I doing? What's the purpose of what I'm doing? And the story goes like this. One day a man was going towards a hill and he saw many people breaking stones. He got curious and asked one of the person, okay, what are you doing? And this person was focused on their work and didn't like the disturbance, But in the end, whatever, he answered, I'm breaking stones. Our man was still curious, right? Like, you're breaking stones? Okay. So he went to the second person and asked the same thing. And the second person got very excited and told him, I'm building a castle. So basically, this is a bit of a, switch of perspective and looking at problems and that the problems that we're solving and the work that we're doing every day from a different perspective. Because as developers, right, we go through phases where sometimes we are just breaking stones, right, doing the task at hand. We have to fulfill the deadline, that's that. But there are other, situations where we feel like what we're working on is actually having some result. There are some people that are working with the product, so we understand what is the scope of the work that we are doing, and we feel fulfilled. And of course, it can also be maybe, when this kind of imbalance appears, it might be also because maybe it's not the right industry to work on. Maybe we lack options. We are burnt out. We don't really care about the product. So it depends on the case. But basically, we always go from being very careful, taking time to ensure that code is clean, scalable, documented. So we are very careful with everything that has planned, before writing any code. And then on the other side, we are having, developers that are focusing on speed, skipping extensive documentation, skipping the meetings, just going faster to market, beating competition and so on. And there is no like a better version than the other in order for us to do work, but it's more about balancing the two. And maybe this is a familiar concept to you, the circle of competence, which is a mental model that emphasizes the importance of knowing your strengths, your limits, and your expertise. And it ensures that you're continuously improving without overextending yourself into areas you may not be fully understanding yet, right? So we have the stuff right? We need to be very, because I was telling you before about, okay, seeing exactly where we are, like reflecting a bit, where am I at this point? So first is the stuff right? What are your strengths, your technologies, languages, frameworks you truly understand at a deep level? Like, be honest about your limits, because this allows you to build confidence, produce high quality work, gain recognition in those areas. Then we have the stuff you don't know, right? You know that you don't know this. So you identify these knowledge gaps of, see what are the areas of interest that you want to grow into, set specific learning goals, take on projects that stretch you just outside your, comfort zone, pair with mentors to try to learn. And then we have this area of the stuff you don't know that you don't know. And this is an area that often in this field we are getting lost, because we need to be very careful about assuming that we're skilled in areas just because they seem related to what we already know. Very, very interesting concept, let's say, or way of looking at things. And this is actually in psychology. There is this concept, the Dunning-Kruger effect, where people with low ability or knowledge in a specific area tend to overestimate their competence, while those with higher ability often underestimate their own skills. And this has been seen in many fields, so it's not something that is happening only in some areas. What I want actually to emphasize with this circle of competence is that we need to be aware of the limits we are setting on ourselves, because those limits are messing up with our mind more than we believe. For example, if you identify as a, let's say, Java developer, right? If I'm saying I'm a Java developer, that's that. And you're going to see also that you're going to avoid certain trainings, you're going to avoid certain speakers, certain conferences, whatever. So you're kind of stuck into that Java world, right? Generally. If you identify as a developer who is using Java, then suddenly you can be a programmer who knows some other things too, right? So you give yourself the freedom to extend your perspective and your knowledge. And you might discover that you like also other technologies. For example, I've seen very, very often, you're working on a product and then you need maybe to change the technology. Maybe it's an outdated technology. And I see in teams that there is this instant fright of, but we are just working with this technology. We don't know the other technology, and it's like, I'm an ex-developer. I don't do the other thing. So it's very interesting to just follow how this also is happening in other areas, in doing system design, in approaching some challenges, some new projects, some maybe a new role. It goes on and on. And basically, why I'm putting this things into this perspective, because we often have the tendency to just think like tech people, just tech. We are just tech people and we are learning technologies, the patterns, the architectures, and that's that. We lack, and I think it starts to change a bit, but I'm not sure. I'm still following the industry, but this kind of changes a bit now that we are talking about AI again. And all this discussions about AI is going to take our jobs and what makes us different. So somehow is challenging us to reflect a bit on the skills that we're having and what sets us apart from just a code generator. And I would like to maybe look on how we can approach a bit problems and share with you some concepts that are going to help you in many areas. Either you're a developer and trying to just solve some challenges on your day-to-day work. You are an architect and maybe looking at the big picture, having to take on very important decisions. Either way, I'm inviting you to change your perspective today with me and see if you can identify areas in your work where these concepts might help you. These are concepts that are helping me and have switched my way of looking at my work, at the challenges that I'm having. So I hope we can discuss it in the end about this more. But we were discussing before about the areas, not knowing what you don't know, because I think that's where we often get lost, right? Because it's difficult to understand the system that we're part of, precisely because we have some blind spots, right? The things that we don't know that we don't know. Some bug appears in production. How could I possibly know that? I didn't know until it happened. So, how can I see that? We don't see what we aren't looking for, and we miss the things that we are not aware that are going to happen. So to acknowledge these blind spots and go there in that final part of the circle, the competence circle that we are looking at, we need something more. We need to approach problems with different perspective. We need to leave the ego behind and be very honest and help and accept that we are continuous students. And we also need to stay close to the direct results of our choices and the consequences of the decisions that we're making. And I think precisely in large organizations, we often become detached from the direct results of our choices, right? Because this very big distance does not allow us to to really understand what went wrong and actually leave us in the unknown, continuing to think that things are just okay. This is something that doesn't really have to do with what I've been coding or doing, and we don't really recognize the impact that our actions have. And this kind of detachment can create the broken window effect, because there is this idea that in urban environments where there is one broken window that is left unrepaired, people are just understanding that as a signal of lack of care, and that place invites more damage. So small unresolved issues in our code, in our processes, in our mindset, since we are discussing about this, can accumulate, leading to bigger problems and issues over time. And if we don't address these issues early, we risk letting poor practices, blind spots take root, making it harder to build something meaningful. And we were discussing about perspective as one of the ways in which we can identify the blind spots, looking at perspective. And I want us to just stop for a moment in this. And I want to do another book recommendation, something that I think I've been reading, I don't know, some years ago. I think actually when it first appeared, it's a series of books, but I highly recommend this one, The Great Mental Models, by Shane Parrish. And in here, we have some very, very useful tools into how to identify these blind spots and how to actually, you're not going to believe it, this is not a tech book, but still, it's a book that is going to open your perspective to a lot of new ways of looking at your work and the way you are making decisions in your organization, in your code, in your processes. And I want to go a bit through some of them, precisely because we were discussing on the perspective part. Relying on just one way of thinking limits our ability to find solution. And great thinking comes from using insights from different fields. I was telling you before about the fact that for a long time there was this discussion, okay, I'm just interested, I just want to do my task. I just want to do my task. I don't care about, this soft skills, or I don't know, all sorts of things. I just want to be very good at the technology that I'm working with, and that's that. But let's switch a bit the perspective on how we used to do things in school. Because in school, we learn about different subjects, right? We learn about math, but then we also learn about history. And we also learn about, at some point, some philosophy, right? Oh, it's because real world problems are not neatly divided like this, right? I don't have only biology and I only have history and I only have, physics. Somehow in the world that we're living, these topics are combining. And without a multidisciplinary mindset, we miss the full picture of a problem. If a single worldview dominates your thinking, you'll try to explain every problem through the lens that you are having at hand, even if it's not the right fit. I guess you heard this saying that to the man with only a hammer, everything looks like a nail. Understanding the complex and interconnected world requires drawing from a variety of perspectives and models. So I'm challenging you again to just look a bit outside of our, very focused techie world and learn from very smart people from other fields. For example, Charlie Munger had this concept of the Swiss Army knife approach. He believed in having a wide range of mental models, similar to having, many tools in the Swiss Army knife. And these mental models come from various fields, right? So we are not limiting only just because he was a businessman or, just on some areas. Each mental model becomes a part of our toolkit, and it helps us to see challenges from different perspectives and find solutions. If I go into a meeting with a developer, a product owner, and an architect, and I'm putting on the table a certain subject, right? Most probably, each is going to have a different perspective, right? And we are not talking here about people that are, combining, because the roles nowadays are very, interesting, combining all sorts of skills and so on. Like I'm talking about pure developer, pure PO, and architect, right? And maybe even to make a better point about this, if I'm going into a forest, right, with with a yoga teacher and with a real estate agent, they are going to see that forest from a very different perspective. Real estate probably is thinking from the business perspective, right, and what it can be built in there and so on. While the yoga trainer most probably is thinking about what an amazing place is this for a retreat. So by relying on only specific disciplines, we can develop gaps in understanding what we are often unaware of. The uh, the the blind spots that I was mentioning before. And of course, we can look also at the Nobel Prize winners, right? We can see that many of them, while specialists in their field, had a very wide range of interest in other disciplines too. And I'm going to give you a very precise example of this relationship between our world tech and a very different, or what seems a very different field. I'm going to guess that most of you, if not all, know the book, the white and blue one, right? Every professional at some point in their career has encountered the design patterns, or the Gang of Four. Yeah, everyone has been reading this and trying to understand, and trying to use the concept. Well, maybe the other one, the yellow one, is not that popular, but it has a lot to do with the design patterns book. So the author of the yellow book, A Pattern Language, Christopher Alexander, is a pioneering architect, like, architect for buildings. And he is the one that actually introduced the concept of patterns. And I really recommend the book. It's very, very nicely written and very interesting. Basically, patterns as the reusable solutions to recurring problems. And through his work in this book, while originally applied to architecture, so to his area of expertise, his ideas have had a significant impact on software development, especially through the creation of design patterns. So we are going to the other book, right? I don't know in which part it is. Yeah, so this pattern helped developers, right, and professionals so many years build systems that are modular, scalable, and maintainable. And exactly the ideas from A Pattern Language by Christopher Alexander inspired the Gang of Four, who adapted this concept of reusable patterns to the book that we know as Design Patterns, Elements of Reusable Object-Oriented Server. So Christopher Alexander's work demonstrates the power of drawing from other disciplines. Urban planning provides models for scaling systems. Biology offers insights into designing adaptable networks. Psychology helps us build user-friendly interfaces. So the most innovative solutions often come from applying insights across fields. Then, if we go a bit further, when it comes to going further to the mental models that we can use in our work, that might seem that are not directly having anything to do with our domain. So we discussed the Swiss tool. If we go further, another concept that I want us to discuss is the map is not a territory, which is a mental model that basically tells us that our simplified version of reality, like blueprints or diagrams that we are working with, are not the same as the actual thing. When we create a diagram to understand something, we leave out details, right? Like a certain diagram, for example, for our system might mean a lot to an architect. And then when a developer is looking, doesn't really understand anything. Or maybe for an architect, a diagram that is being done by a developer is, not, or with too many details. And I'm just trying to differentiate the two. I'm using these two roles in order to, make a point. Again, of course, there are organizations that have these roles very well combined. But I'm trying to make the point of the discussion. So these diagrams or these blueprints are as useful as what you want to do with them. Just a second. And I took the liberty to actually show you this. So if I'm looking at this, it's telling me, right, is a map from somewhere from my city. It's telling me, okay, you're going to do 16 minutes to your destination. This is how it looks. This is pretty much how the street looks. Then if I'm going a bit zooming in more, I can see also other buildings that are in that area. A bit more clear, the road that I'm having. If I go a bit even more in details, I'm going to see even more streets, more details, more information. So if it is to translate this to our domain, we can think of the map is some high-level architecture diagram that is providing an abstract view of systems components. The interactions that those components have, the data flows. But in territory, the actual system's behavior in production can be far more complex can involve all sorts of interactions, failures, performance issues, and so on. So even if I'm looking at a map generally, I can see, okay, it's going to take how it was before, right? 16 minutes between the two points. But it doesn't say exactly if maybe, I don't know, there is some hole in the somewhere in the street, or if someone is riding their bike very, very slow, so I need to wait after them, or all sorts of things that I can see on the map. I just have to be there in order to understand that. So by understanding this mental model, for example, in software architecture, we can do our work with flexibility in mind, and we ensure that the system that we're building is adaptable to unforeseen challenges. Um, it's actually having all the failover mechanisms in place in order to, be ready for real life situations. And you might be thinking, okay, but how do I get these details in the map as soon as possible? But let me tell you another story. There is this story that at some point, British government wanted to reduce the number of cobras, right? So they offered a bounty for every dead cobra. Initially, this seemed like a good idea as people started killing the cobras, which, okay, works very well. But there were some people that realized that they could breed cobras and then kill them for the bounty. And therefore, they were creating a cycle of increasing profits. So when the authorities discovered this, they stopped the bounty program. They just thought, okay, if we are stopping this, the result is going to be that, the breeding is not going to happen anymore. But in response, the cobra breeders, because they had no use anymore for those snakes, released them, causing the cobra population to surge even more than before. What was this government lacking? The second order thinking. They were just thinking very linear. If I do this, if I do A, B is going to happen. But if we use second order thinking, basically we learn to look beyond the immediate consequences of our decisions to understand their long-term effects, as well as ripple effects that may arise from this decision. So not only A to B, but also A to B, to C, to D, going back to B, and so on, right? So again, the world is more complex than just a linear kind of cause and effect kind of ruling. And let's take, for example, the scenario of building a high traffic e-commerce platform, right? Let's say we have a team that is tasked with designing the architecture of a new e-commerce platform. And okay, the first concerns what are? Okay, feature development, building product listings, a shopping cart, payment integration, user management. You might even, decide to prioritize performance to give your users a good experience. But by considering the second order effects, you start thinking beyond the immediate functional requirements and ask yourself, okay, what happens if traffic spikes dramatically during a promotion? What happens if part of the system fails? What if actually the payment component is failing? How easily can new features be added as the business evolves? How will this system scale as maybe your platform is going to be so popular that is going to scale overnight? What are we doing with this new information? And the list of questions goes on. So it's not only about, okay, I have this list of requirements, I'm building it, and then I'm just like, okay, bye-bye, we finished, let's go to the next task. No, it's about asking the right question, and then we can go even further, with third order concerns. And of course, we might get into either very general or very specific, but the idea is that blind spots in our thinking are revealed by asking questions, thinking beyond the obvious. This approach can help us anticipate what we were discussing in the beginning, the consequences that we don't want to happen. Helps us plan for future needs. Even if we are not over engineering something, it's still good to understand if we are on the right path with the solutions that we are taking. And we avoid, most importantly, because I think that in this world where we are speeding so much, looking at second order concern or third order concerns helps us avoid quick fixes that lead to long-term problems. I'm just going to make it work now, and then whatever happens later, I'll deal with it later. It might become a very important thing. Choose wisely in what you're actually doing workarounds for. And the thing about blind spots is that sometimes appear also because of full focus, being completely absorbed. And you know what I was telling you before about I'm just working on my side. I'm just coding at my task. I'm just okay with this. I don't need to understand the business very well. I don't need to understand the impact very well, because if this is what they are asking of me, I'm just going to do it the way I know, and that's that. And because I feel like telling stories, and actually it's a very popular one, but it really emphasizes the idea that sometimes even out of full focus we might make some mistakes. There is this allegory from David Foster Wallace that is telling us about two young fish swimming along, and they happen to meet an older fish swimming the other way. And he looks at them and nods, "Morning, boys, how's the water?" And the young fish swim on for a bit. Then eventually one of them looks over the other and goes like, "What the hell is water?" So we cannot really make a decision for a system that we don't really understand. And relativity, another mental model, involves understanding that things are not absolute and often depend on context and perspective. And in software development, applying this concept means considering how different decisions, processes, and outcomes may vary depending on the context. And my favorite example for this is choosing a technology. When we are trying to use a technology, often I see this thing about, okay, this new technology appeared, right? It's promising to fix all my problems. Like, it's amazing, it's just heaven sent. And we are not analyzing the context of our product, our business, and so on. And then we're putting that technology in there because, I read the specification and this seems great. And then we are realizing that, okay, this is not what I actually need, and I have a lot of problems now and a lot of integration details and so on. Well, instead of asking what is, for example, the best programming language, we apply relativity and consider the context in which we are making this decision. What's the team's existing skills? What is the ecosystem and the tooling support that we're having? What is the timeline that we're having? Do we have time to actually teach the team a completely new technology? So we need to understand that what might be good for a certain context. We hear, I don't know, at a conference, we hear in a training, we see a YouTube video, whatever it is. It doesn't necessarily mean that it's going to go very well on my side too. Try to understand the business, try to understand the technology and the context of the team, try to understand the implications of integrating that new technology into your product, and so on. And then make the decision, because there is no absolute best answer. What matters is the context in which the decision is made. Then, when discussing about absolute things, right, we have this tendency of always looking the steps for success, and this is not only in in our domain. We look the steps for a good relationship, for becoming rich, for having the best architecture, whatever it is. Always, some very specific steps that we can follow and check, and that's that. Well, what's with with this obsession on brilliance and perfection, few titles of 10 ways in which you can ruin something, right? I want to see this. I want to see 10 ways in which I can damage very much the architecture or very much the product that I'm working with. An inversion model suggests that instead of always striving for perfection, it's often more effective to focus on avoiding mistakes. And a very, very nice concept is chaos engineering. Maybe many of you are using this, but basically is the practice of deliberately introducing failures or disruption into your system to test how resilient it is in and also how good is its ability to handle unexpected conditions. So if we go back to the platform that we were discussing before, okay, let's say it's Black Friday and it has to remain working very well. And normally the focus would be on ensuring everything runs smoothly, optimizing for performance and for uptime. However, using the inversion mental model, the team starts to ask, what if things go wrong? And by applying chaos engineering, we start simulating failures. We shut down random servers. We introduce network latency during peak traffic. This tests how the system responds under stress, whether load balancers, right, reroute traffic effectively, if database is handling the sudden load, whatever, all sorts of scenarios that we cannot, see, so blind spots that we cannot see unless we are just creating a random kind of behavior, just as a user might have at some point. So this approach shows us stuff we don't know, again, on the circle of competence. And by using this kind of approach, we ensure that the platform can handle real world disruptions when they actually occur, because we are focusing also on what could go wrong, not only on how perfect I want it to work, because this is very subjective. And very interesting fact is that when we think, it's a thing that I also saw in our domain. The more complex is something or hard to understand, the more interesting it seems, because we need to understanding. This is our nature, right? We are trying to solve problems, and that's how people get in all sorts of toxic relationships. Like, no, it's not. We don't have to chase the this kind of very interesting and hard to understand and more complex and more challenging, because what I'm trying to say, jokes aside, we often underestimate simple ideas and overestimate complex ones. And I've seen along my career, I had peers that uh, they felt valued when they were able to know something that no one else did. Even if it wasn't really something that we could apply into our system. They were trying to develop some sort of unique expertise to set themselves apart, often rejecting simpler solutions they wanted to ensure that others can't easily contribute to what they have to offer. Like, yeah, okay, this is a good solution that we're having. It's actually working very well for what we have. But here, I've been researching this and it's more complex, yes, but look how interesting it is. So there is this mental model called Occam's razor that suggests that when faced with multiple competing ideas or solutions, the simplest one is usually the best starting point. So in software development, this principle encourages choosing simple solution over complex ones, unless there is a compelling reason to introduce, additional complexity. And with experience, this can be sensed. You can think about, okay, we are going back to our application. After a new update, something happens. Our application starts slowing down, right? And users start complaining. And the team gathers and tries to figure out what is happening. And some things it's a server issue or a problem with a third-party service. But one developer in the team has been to this presentation and remembers this concept of Occam's razor and the fact that the simplest explanation is often the right one. And instead of chasing the complex scenarios, they think, okay, I'll just go and check first the recent code changes. Sure enough, a new query was slowing things down, right? Fix the query, the app runs smoothly again, problem solved. We didn't have to spend a lot of money on, I don't know, doing some infrastructure changing or whatnot. So lesson starts with the simplest explanation because it saves time and effort in actually having some problems resolved in the end, because that's the end goal. And of course, as are these concepts that I presented to you today, there are a lot others. And again, I strongly recommend to you to just look on the internet. You don't even have to buy the book. Just look on the internet, mental models, and then just try to see how those would apply. Just make an imagination exercise in order to see how those models would apply into your context. Because yes, things are changing in our domain. You see how things are evolving. We need to find in ourselves the power to grow as professionals, to uh, learn more, but not only learn more, but learn what to do with the information that we are knowing. So it's not a thing about memorizing stuff, but more like knowing what to do with the concepts that we are learning. I think this is where the true power of a technical professional engineer is going to be. Of course, I can't predict anything because you see how things are evolving, but from what I've seen. And it's not about just knowing more mental models, because tools and languages, are powerful. They are helping us a lot, but our mindset, as I was mentioning in the beginning, really defines the impact of what we create. They help us navigate complexity, make better decisions, anticipate future challenges. And because I mentioned Christopher Alexander, he reminds us that when you build a thing, you cannot merely build that thing in isolation, but must repair the world around it. And this is the essence of a true developer's, engineer's mindset. Understanding that every piece of software contributes to a larger system, shaping the user experience and the technology landscape itself. So in the end, if it is to go a bit back to the first story that I told you I learned some time ago, is that always try to build castles and don't just break stones in your work. Thank you very much. And yeah, let's chat.
So thank you very much. From my side, I think it's a very good session, and I'm very happy to be part of this session, talking not about technology, but also about mindset. I think it's very, very important. Do you hear me? Just to be sure it's okay on your side.
Yes, we can hear you, Rodrigue. Yes, it's okay.
Yeah, I have one point I want to. Sorry, Seme, your mic. You need to block your mic. Yeah, it's okay now. Yeah, good. Thank you. Listening to your session, I couldn't help but think about Husserl's phenomenology. I think it's a philosophy I learned when I was young. The idea that we shouldn't return to the idea of the phenomenology is that we should return to the essence of lived experience, suspending assumption to truly understand what appears before us. So, do you think developer could benefit from a more phenomenological mindset, if I can say, one that encourage them to observe their code, or simply code and process as they are experienced rather than they are supposed to function. It's something that came in my mind when I was listening to your session.
Yeah, it's a very, it's a very interesting. I keep going back to this. It's a very interesting time that we are living. What a time to be alive and a developer or a tech
Yeah.
person right now. And I'm also seeing all this. I see. I think once a day or twice a day, someone hating on AI or loving AI. So is going from 0 to 60 and like, okay. And what I see that it's I think this kind of stuff also appears out of fear and out of lack of confidence.
Yeah.
And I've also found myself into this position. In the beginning, I was working with ChatGPT and with Copilot, and I was like, oh my god, this is amazing. And now even with the latest updates and so on, so I really think that we need to take a step back.
Mhm.
As I said, be completely honest about, first of all, why we joined this field, because I don't know how it is, in your country, but in here I saw some years ago there was this hype, especially in the pandemics. Everyone was willing to be a software developer, like everyone. There are a lot of schools that were teaching you in 3 months, the basics, and then you're just joining this field and so on. But right now, it seems to me that it comes a time when we need to actually, first of all, like what we're doing and be
Mhm.
passionate about, not only
Mhm.
chasing, the resources, and then have the ability, yes, to step away, to try to understand systems, because we are not just coding stuff. AI tools can do this, and they are doing it pretty good. We need to step away and see exactly, look at the system. Uh, Actually, it might seem like strange, but actually try to work on our creativity. Try to understand, as I was saying also in the presentation, other fields too. What we can learn about how these systems are developing. How can I actually improve my with my system with the help of other concepts, not just what I know. Not just the rules for the language that I'm using, because even I think even a developer has to strive to know more than just know some system design, know some architecture. It's not, at least in here, the the requests in interviews are being very general now, not that specific anymore. So the expectations are very high, and a decision has to be made from the perspective of each of us, and actually try to switch a bit the perspective from just, okay, I'm very good with X language, I'm the best, I'm very efficient, I'm writing code very very fast, so yeah, I'll find a job. Things are changing a bit, and we need to be honest and take that role of a student yet again,
Thank you.
as always, actually, right? In this field, I don't think there's a time when we can just say, okay, I know this technology, and I just won't learn anything anymore. Everything is evolving so fast. You need to be up to date, try to understand now how to integrate these tools, how to make the most of them. So it's a never ending kind of process and learning experience.
Yeah, thank you so much. Simi, maybe you have a question?
So, can you hear me?
Yeah.
Good. So, first of all, I wanted to thank you, Michaela, for this presentation, for all those details and all this mindset that you have, and all those topics you have presented. And I'm sure that based on this, only one session wouldn't be efficient to cover all those topics. And of course, we will keep in touch with you, and we'll be very happy to have you with us in our upcoming sessions with more focused, let's say, topics in more details. Uh, I don't have any question, so just because I see the time is we are over, so we have finished. But let's say that keeping in touch and trying to have or arrange other sessions will be very, very interesting, will be very efficient, seeing the type of knowledge you have, and also the topics that we covered for this session. Thank you very much once again. That was very interesting, and with Rodrigo, of course, we will keep in touch with you.
Thank you for having me. It was
Thank
really,
you.
really nice meeting you. And yeah, I can be reached on LinkedIn mostly. So anyone who just wants to
Of
say hi
course.
or maybe ask anything, if now maybe it's too shy to do it, please reach out.
Okay,
Sure.
so
Thank
for
you.
that, yeah, you're welcome.
Thank you very much, Michaela, and see you soon. Have a nice day. Thank you.
Thank
And
you.
have a
Bye
nice
bye.
weekend too.
Bye bye. So do you.
Thank
Have
you.
a nice weekend.